Welcome back to CAD/CAM tutorial. Today we are going to create a root type blower with 3 lobed rotor in SolidWorks. Here we will create each and every part separately, then we will assemble, and at the end we will make this simple animation. I hope you like it. Let's create the first part of root type blower housing. So here we will start with, from this front view, you will see there is a oblong slot 96 millimeter. You will see 96 into 192. See, the thickness or width we will make 150 millimeter. Then backside there is a wall. You will see there is dotted line. This wall thickness 10 millimeter. Okay, and backside there is a hole also. This 20 diameter, and 89.69 is the distance between these two. So let's do this first. Front plane sketch. Now here I'll choose a straight slot. This radius shows here 96 millimeter, and this distance 89.69 millimeter. That's it. Now we will extrude this one, and we will extrude this one up to 10 millimeter. Say yes. Now again I'll choose the same plane, front is plane sketch. Now I'll choose the previous sketch, convert entity. Now it's converted, circle. Let's create our 2 circles, 20 millimeter, 20 millimeter. Now you will see this circle 139.5, these two. So this portion we will extrude up to 150 millimeter from front plane. .5 millimeter. The similar we are going with this. Okay, that's fine. Now let's extrude. Now what we need to extrude here, I'll choose this face. See, here keep end condition blind and 150 millimeter. You will see here. Say yes. Again I'll choose the same sketch, extruded cut, and this time I'll choose these 2 holes, and I keep end condition through all. I think we missed something. Sorry, make reverse. Oh, that's it. The hole is created. Now let's make outer wall. Outer wall, you will see this wall, then there is this slot size 111 millimeter, but this length you will see here. Let's see here. This is actually 100 millimeter. Okay. This one actually 100 millimeter, and this one we will create up to the end wall. See here, you will see inside section view. Then we will create this hole. This hole diameter 10 millimeter, 30 millimeter deep, 15 number of holes, and here you will see distance 13.125 from this end. So I'll choose this face, sketch. Again I'll choose the same straight slot. Let me choose this 1111. Now right click, select loop, convert entities. Okay. Okay, let's create a line. Now select, okay, there is too many things, so mirror entity, see here, make sure this is vertical, mirror. I'll choose these two lines, mirror about this section, say yes. Let's define the distance, 100 millimeter. Trim entities, okay, let's define trim letter. First make close geometry. Now here no need, because we have only 3 lobes. Trim entity, now it's time to trim. Even though you don't need quick power trim, move your cursor. Even though if you move, we will define this dimension first, so that our geometry should be fully defined. That's it. Even though you now let's try to use extruded boss. Here we need this one, and this close geometry. Take it reverse, select through all, see up to the wall, say yes. Now let me choose this sketch. Now I'll select this one, convert entity, or even though if I am going to show center line, millimeter. If you check the distance from this end to this end, 13.125 millimeter. That's it. Click this one for construction purpose. Extruded cut. Now this depth is 30 millimeter. Now let's hide. Now here we will use curve driven pattern. First we need to choose sketch. So I'll choose first sketch. That's why I create only one first sketch. Now here feature this one. Number of instances 15, equal spacing, and keep offset curve. If we keep transfer, it will go out. See? So always keep offset curve. Say yes. Look. Now let's make upper part. Upper part is 30 millimeter from this one. Then there is one more 10 millimeter long, and this diameter 160 millimeter. This inside diameter you will find 120 millimeter, and there is one hole, 80 diameter hole. This hole we will make. Then this also there is one more hole, 15 diameter hole, and depth 40 millimeter and 52 millimeter. 52 mm actually is the gap. So I'll choose this face, sketch, circle. Okay, first let me choose diagonal so that we will get easily 80. Enter. Again I'll choose 120. Enter. Okay. Let's extrude. This one I'll extrude up to 30 millimeter upside. Say yes. Again I'll use the same sketch, cut, but this time in selected contour I'll choose this inside, and here I'll select up to next. You will see it's going to cut up to this end. It's forget to add something, edit feature, and okay, we forget to add here this half end also. That's it. A sketch circle. Now this outer circle is 160 millimeter. This select inside circle, convert entities, extrude. Keep end condition only 10 millimeter blind. See, it's moving upside. A sketch. (15). Now the distance from here to this 52 millimeter. Say yes. Okay. Now we need to define some center line. So simply create a sketch and find center point. Horizontal. Now it is fully defined sketch. Extruded cut, and this depth here shown 40 millimeter. Keep end condition blind, and 40 millimeter is the depth going to create. Now here we need to do something more. Okay. Now for this face, extruded boss base, it's moving in one direction. So click direction 2 also, and in direction 2 up to next. Now that's it. It patches up to here. Let's uncheck so that we will get perfect. Circular pattern. Here we need to choose any circular faces. See, clear, choose hole. We need 8 number of holes, 360 degree equal spacing. Say yes. Now this chapter is finished. Now let's make exit and inlet port. Now here see, this is 200 millimeter from center to here distance, 120 outer flange, 90 this inner flange, and 60 millimeter this is the hole throughout. See here, and you will see there is 8 number of holes, 10 millimeter hole depth 30, and 37.5 is the distance from here center to hole, and this is also 8 number of holes. So first we need to create a plane. So where is our center plane? Okay, our center plane is not on position. Plane, I'll select 1, 2. Now see a mid plane going to create. Say yes. Now choose this plane, again select plane, and here choose distance 200. See, it's going to create a plane up on 200. Select the plane, sketch, center line. Let's draw one center line so that we will get a center position. Inside hole 60, 90, 120. Okay, let's try each and every one by one. Now in selected contour, I'll choose 1, 2, reverse up to next, up to this wall. Okay. Again, let's choose the same sketch. click sketch, extruded boss base. Now this time I'll choose this flange, outer flange. This is 10 millimeter and it's inside. Click inside, say yes. Now the last one is hole, extruded cut. This time I'll choose this and here I'll select to next. If I'm going to choose next, it's going to select inside wall. Now see, the hole is created. A sketch, 10 millimeter this circle, and distance from center to this point 37.5 millimeter. Okay. Now I'll choose this point and hold shift key, origin point, horizontal. Now depth is here 30 millimeter. So I'll choose extruded cut. Keep end condition blind and 30 millimeter the depth. Circular pattern. I'll choose here, first choose feature, this one, and here you need to choose any axis or any circular rotation. I'll choose this circular face. Equal spacing 360, 8 number of instances. Say yes. See, the 8 holes are created. Now let's hide those planes. Now it's time to mirror this one, this feature. So I'll choose this mid plane what we created, mirror. Now plane is features to choose here, just drop down 1, 2, 3, okay, 2, 3, 4, and circular pattern also, say yes. Now let's try, okay, all the things are perfectly mirror. Let me hide. Here next thing we need to create this fins. There is 8 number of fins. You will see at bottom 10 mm fin and there is gap also 10 mm. And the distance of fin is 8 millimeter from inside one. See, so we will create this one 10 millimeter, then we will use linear pattern to create. I'll select this face, a sketch, center straight slot, I'll choose this slot and this slot. Click here, make cordial. That's it. Now again offset. Set here 8. Select this one. See how it's going to create. Say yes. Okay. Now convert entities. Convert entities. Because we need to close the thing. Convert entity. Now we have closed geometry. I'll show you how. Extruded boss base. Now I'll select 1, 2, and this bottom one 3. Okay, these 3 we want to create 10 numbers. Now see, it's moving outside. Make reverse. Merge result. Okay. Now see. Linear pattern. Here we need to choose axis. So I'll choose this axis. 10 is the distance, 8 number of lobes, feature. Feature, you have to just come down and choose extruded boss base. It is moving wrong direction, so reversed it. And this one keep 20 millimeter, because 10 millimeter is the thickness and 10 millimeter is the gap. So perfectly you will get 8 number of lobes. Say yes. 1, 2, 3, 4, 5, 6, 7, 8. Look. Okay, so this is the our blower body ready. Let's assign some color. I'll choose some plastic color. Okay, let me save. Root blower. This is part number 1, housing. Okay, so let's make the next part, cover. Part of blower is cover. See, the outer radius 96 millimeter, thickness 20 millimeter. Okay, then inside, first we will radius 139.5. This is same as what we did in housing. 15 number of holes, 10 diameter throughout hole, 20, 89.69. Sketch front plane, straight slot, (96 millimeter), 89.69 millimeter, and this thickness extrude 20 millimeter. Okay. Now again I'll choose the same. Okay, let's choose this 139.5 millimeter. This is also 139.5 millimeter. 20 millimeter, 20 millimeter. Now the distance between these two, 47, sorry, 89.69. Horizontal relation. Now let's try here extruded cut. I'll choose this one and this one. The depth here is 10 millimeter. Keep end condition blind 10 millimeter and it inside. I'll again use the same sketch extruded cut command. Here I'll select these two holes and here I'll choose through all. Look, this face, draw one center line because our hole located in center of this, 10 millimeter. If you check the distance, it's 13.125 millimeter. Extruded cut and end condition is through all. Now again I'll use curve driven pattern. Here we need to choose first sketch because first sketch is only one closed geometry. 15 number of holes, equal spacing, offset curve, and here choose feature. Now see the hole is going to predict. Cover. Let's make next part. Now this is impeller or 3-lobe rotor. This rotor diameter 45 millimeter, distance from center 47, and the center circle 20 millimeter. There is one key slot 4 by 4 at center of the circle and 5 number of slots. Then this radius, this flange 22.5 millimeter, and there is 3 lobe. Okay, first 20, 45. Let me define the distance 47 millimeter. Now let's make some relation first. Horizontal. Now it is fully defined. Circular pattern. Here choose center point, this one. Entities to pattern, select this circle. Here keep 360 equal spacing, 3 number of instances we need. Say yes. Now it is not fully defined, so simply click fully defined, calculate, okay. It will add some dimensions and our geometry fully defined. 3-point arc, 1, 2. Now hold shift key, tangent, dimension, smart dimension, 22.5 millimeter is the radius. Now again we will apply the same what we did, circular sketch pattern. First center point, entities to pattern, this one. Here also 3 number of patterns, equal spacing 360 degree. Now see, it is not fully defined sketch. Again apply fully defined sketch. Selected entities 1, 2. Calculate. Okay. It's fully defined. No need to define anything else. Extrude. This length is 150 millimeter. Keep end condition blind. Let's apply some material. Brass brushed. Impeller. Now here we forget to add keyholes. Circle, choose rectangle, and here's select center point rectangle and find out the midpoint. Okay, 4 tap, 4 adder. Now this one choose extruded cut, and here keep end condition through all. Say yes. Circular pattern. Here I need to choose one axis, 360 degree, 5 number of patterns and feature. The last one you will see. Let's move. Fourth part is shaft. Shaft length is 215 millimeter, diameter 20. Then there is key, 4 key slots, and this key also same 4 by 4, 5 number of keys, and 150 millimeter long, and from one side 40 and other side 25. I'll show you how. Front plane, sketch, circle, 20 millimeter. Center rectangle, 4 tab 4 enter. It's not defined, I think. Now let's try for this extruded boss base. Now here I'll choose this circle. Keep end condition blind 215 millimeter long. Say yes. Again I'll use the same sketch, extruded extruded boss base, and this time I'll choose this one. Choose this closed geometry. See, keep end condition 150 millimeter. Offset 40 millimeter from this side. Now select this one, circular pattern. I'll choose this circular face, and 5 number of patterns we need, 360 degree. See, okay, let's save part number 4, shaft. Gear and bolt we will take from design library. So let's start assembly. Now here open new assembly. Okay, now first part I'll choose, just drag and show coordinate system, view origin, and connect to this point so that our geometry located at perfectly on center. Hide it. First part by default always insert component. Now select all these 3 parts. Met. Let's fix this first. I'll select this hole and this one. Okay. Now select this one, this face and this face. Here select distance 30 millimeter. Take it okay, that's we want to come out 30 meter outside in here. Now again press Ctrl key, drag and take outside. Copy, just simply a method. Clear hole and concentric relation. Okay. Here again put distance 30 millimeter. Say yes. Okay. Now I'll drag law. Select this one and concentric relation. That's fine. Now let's fix this slot. So here select matte, clear, and I'll choose this wall and this wall. Coincide relation, say yes. This face and this face. Coincide relation. Okay. Now this one fixed. Control key, click and copy. Met, shaft and the circular face, concentric relation. Okay, just take near to key, this face and this face, coincide. Key face and the loft face, okay. Now these are the fixed. See, now let's rotate. Now see, this is parallel to this, so and this hole is parallel to this, so this hole should be here. Take care to fix this hole, because in one side you will find two hole and one here, because there is a odd number. Let's choose this one. Okay, cancel it first. Now let's, okay, that's already fixed. We will fix this one at the end. Let's make mechanical mat. Gear. Click gear, this one and this face. Here 2020 no more reverse, say yes, close. Now let's try to rotate. Oh, that's perfect. Now let's try to fix this mat, this hole. Now you will see the holes are not going, okay. Okay. Now this shaft and this hole, concentric relation, that's fine. I'll choose this face, coincident. Now okay, holes are matched. Now let's assign some bolt, nut bolt. Go to library, okay, tool matrix, bolt and hexagon, and here I will choose this flange, heavy flange. Just drag, keep your cursor near hole and face. This is 10 hole, so we will choose 10, and here keep length 50 millimeter, because this is 20 and the depth is 50 millimeter. Say yes. Now just it will ask you need more, so just move your hole and face, hole, face, hole, face, and click. No need to, it will automatically see the hole selected. If you move face, click, face, click. This is the best way to apply it. It saves lots of time. Okay, now the holes are fixed. Let's come here. Metric, power transmission, gear. Now we will use here spur gear. Just drag to here. See the one relation created. Keep module 3, number of teeth 30, pressure angle 20, face width 15. Okay, that's fine, 15. No, we don't need hub. Shaft diameter 20, because our shaft is 20. Say okay. Now it will ask you need one more. So just move your cursor near this. Okay, cancel. mat. Choose these two faces, go inside shaft, concentric relation. Now here let's fix this one with this shaft. I'll choose top plane of shaft, come down, this is the gear, hold control key, plane 2, click mat, coincide, OK. Now let's come to other shaft. This is the last one, is per gear 1, shaft, right plane. Here I'll choose right plane, not top plane. Come down, press control key, plane 2, mat. See, it is perfectly going to align with this. OK, close. Now, if you rotate, see, it's going to rotate because we already set lobe there. Now this assembly is finished. Let me save this assembly. Let's hide, save, right click, go to tool, motion analysis. Okay, it's already selected. Keep animation, I'll select frame 50, just drag this up to 10 seconds and let's apply motor, and let me choose this one. RPM I'll choose 20 millimeter and okay, 20 RPM, say yes. Now click calculate. It's calculating. Once finished, now let's play. See how is motor going to play. So don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.